A single, handwritten annotation changed everything. It was August 15th, 1977, deep in the night at Ohio State University's Big Ear Radio Telescope. Dr. Jerry Amon, a volunteer, was sifting through reams of computer printouts. Then he saw it, a string of alphanumeric characters, so anomalous, so powerful, that he circled it in red ink and scrawled a single word beside it. Wow! This wasn't just another blip. This wasn't static or terrestrial interference. The signal, designated 6EQUAGE5, showed all the hallmarks of an intelligent, non-natural origin. For 72 seconds, it soared above the background noise, then vanished, never to be heard from again. It remains, to this day, the strongest candidate for an alien transmission. The implications were, and still are, staggering. If this truly was a message, it wasn't just a whisper in the cosmic dark, it was a shout. But what was it trying to say, and why did it only appear once? These questions have haunted astronomers and the public alike for decades, fueling both skepticism and profound hope. To understand the significance of the WOW signal, we need to step back and appreciate the context of its discovery. The search for extraterrestrial intelligence, or SETI, was still in its relative infancy. Pioneering efforts like Project Ozma in 1960 had laid the groundwork, but the technology was crude by modern standards. The Big Ear telescope itself was unique. Originally built to map radio sources across the universe, it was repurposed for SETI in the mid-70s. Its design was not a dish that swiveled, but a fixed, colossal structure relying on the Earth's rotation to scan the sky. This fixed nature would later become a critical piece of the WOW signal puzzle. The signal itself was detected at a frequency of 1,420, 4,556 MHz. This isn't arbitrary. It's precisely the hydrogen line, the fundamental frequency at which neutral hydrogen atoms emit radiation. Hydrogen is the most abundant element in the universe. Many SETI researchers believe this frequency would be a universal hello, a common language of physics. What made the signal so compelling was its narrow bandwidth. Terrestrial interference, like a satellite or aircraft, tends to be broad across the radio spectrum. Natural astrophysical phenomena, like pulsars or quasars, also produce wideband signals. The WOW signal, however, was incredibly focused, almost laser-like. Furthermore, its intensity profile matched what you'd expect from a distant, fixed source passing through the Big Ear's stationary beam. As the Earth rotated, the source would enter the antenna's view, peak in strength, and then fade away over exactly 72 seconds, the precise duration the Big Ear could observe a point in the sky. But here's the kicker. The signal was observed in only one of the Big Ear's two feed horns. The telescope had two receivers, slightly offset, that would pick up signals from two adjacent regions of the sky. If a signal were truly extraterrestrial, it should have registered in both horns as the Earth's rotation swept it through. This single horn detection has been a persistent puzzle. Was the signal just too brief to register in the second horn, or was it something else entirely? This detail has fueled some of the more grounded, though perhaps less exciting, theories about its origin. Repeated attempts to redetect the WOW signal have all failed. Countless hours of observation, directed at the precise region of the sky where it originated, the constellation Sagittarius, have yielded nothing. It's as if the cosmic sender transmitted once and then fell silent. This lack of repetition is the biggest hurdle for the WOW signal being definitively labeled an alien message. If it were a deliberate transmission, wouldn't they repeat it? Or was it a one-time beacon, a cosmic ping sent out to see who might be listening? Over the years, various hypotheses have emerged to explain the signal without resorting to extraterrestrials. One of the most popular involves passing comets. Comets are surrounded by vast clouds of hydrogen, and some researchers have theorized that the hydrogen from a passing comet could have generated the signal. In 2017, a study proposed that two specific comets, 266P/Christensen and P/2008Y1 Linear, were in the vicinity of the WOW signal's origin point in 1977. However, this theory has its own challenges. Cometary emissions are typically broadband, not the narrow, precise frequency observed. and the specific comet positions are still a subject of debate. Another less exciting but scientifically plausible explanation is terrestrial interference. While the signal's characteristics made this seem unlikely at the time, our radio environment is far more complex than we often realize. Could a rogue military satellite or an unknown experimental transmission have caused it? However, the 1420 MHz frequency is protected internationally precisely because of its significance to radio astronomy and SETI. It's a quiet band, specifically reserved to listen for cosmic whispers. Any terrestrial interference at that frequency would be illegal and highly unusual for its duration and precise characteristics. So where does that leave us? The WOW signal remains an enigma. It exists in a fascinating limbo between definitive proof and complete debunking. It's a tantalizing glimpse, a cosmic what-if, that continues to fuel our imagination and drive the ongoing search. The story of the WOW signal isn't just about a single anomalous blip. It's about the human desire to connect, to find out if we're truly alone. It underscores the immense challenges of SETI, the vastness of space, the fleeting nature of potential signals, and the difficulty of distinguishing between the natural and the artificial. Perhaps the greatest lesson of the WOW signal is not what it was asterisk, but what it represents asterisk. It's a powerful reminder that the universe is vast, full of unknowns, and that the greatest discoveries might be just a single, unexpected data point away. Today, SETI efforts are more sophisticated than ever. Projects like Breakthrough Listen are scanning billions of radio channels, using powerful telescopes and advanced algorithms to sift through the cosmic noise. We're better equipped to detect and analyze such signals than we were in 1977. But despite all this progress, the WOW signal remains unique. It stands as a testament to the unexpected, a solitary beacon in the history of our search. It's a ghost in the machine, a whisper from the void that continues to echo in the halls of scientific inquiry. Whether it was a comet, human interference, or indeed an alien message, the WOW signal forced us to confront the possibility that we might not be alone. It opened a loop in our collective consciousness, a question mark hanging in the cosmic void, waiting for an answer. The search continues, fueled by moments like these. Moments that remind us how little we truly know about the universe and how much more there is to discover beyond our tiny blue marble. Delve deeper into humanity's cosmic encounters by exploring the Fermi paradox in our next video.